Now we complicate things a bit. Everything we set up to here is about the function g. If there's also a function f, some function f of xy unrelated, and presumably unrelated to g of xy, there might be a relationship, but there doesn't have to be, and we just want to think that f of xy is totally unrelated to g of xy. Okay? Then, at the point here where we have unit tangent, or a tangent vector, it could be unit tangent vector, and the gradient of g, again the direction of no change in the direction of maximum change, this function f presumably has a derivative. Now formally we'd say, okay, at every point of the curve g of xy, at least in some domain, including a continuous segment of the level curve g of xy, f of xy is both defined and differentiable. In that case, we can do del f. If that's not the case, well, we're not worried about that situation. The only situation we're worried about is where the gradient here makes sense. And you have a level curve of a differentiable function g. Okay, so in general, your picture is going to look like this. Now, del f could be in any direction at all. Okay. Now, at this point, the way I've depicted this, del f has a component in the direction of the along the line through the point parallel to the unit tangent vector. That is, in the direction of motion along the curve g of xy. So as you move along the curve g of xy, you get to this point. Remember, this is the direction of no change in t. This is the direction of the gradient, the direction of maximum change in g. Okay, direction of no change in g, direction of maximum change in g. If del f is in this direction, it has a non-zero component in the direction of the line, tangent line, at this point. Now that direction is opposite the direction of t, so if del f is increasing in this direction, which it is, this is the direction of maximum increase, maximum rate of change, then f is increasing as you move in this direction. And that's opposite the direction of t, the direction in which you have no change. So in the direction of t, in the direction of your tangent vector, the function f is decreasing. Okay? Now, what we're interested in is finding points on the curve where f, your function f, has either a maximum or a minimum. You could maybe think of this, and I think maybe the most accessible example, at least the most accessible example I can think of is, okay, in the plane, you have various sources of heat. You know, you have a heater here, a heater here, a heater here, and you're heating up some kind of a metal plate. Well, you have a temperature distribution over that plate. So f of xy might be your temperature function. So at this point, the direction in which to move if you want the temperature to increase as fast as possible is the direction of the gradient of that f function. So that the temperature is increasing most rapidly in this direction. If you're moving along this curve, then if you're moving in this direction, the temperature is decreasing because the temperature increases if you move in this direction. It increases because if you move in this direction, because this is a component of del f. Okay? If it's increasing in this direction, then it's increasing in this direction. If you're moving in the direction of t, then the temperature would be decreasing. Now, if we want to find the point on this g of xy curve, g of xy equals 0 curve, this level curve of the function g of xy, we're going to be looking for a point where there's no change at this point. We're going to be looking for points of this nature where there's no change. So clearly, if del f is in this direction, there's a rate of change of t. So this is not a point where t isn't changing. If you want a maximum temperature or a minimum temperature, you want the temperature not to be changing as you move through that point. So if the point of maximum temperature should have a 0 rate of change. If it has a positive rate of change, it's going to be going up. If If it has a negative rate of change, it's going to be going down, but that means it was up right before you got to that point. Okay, so that's the idea. So my question is, how would del F and del G and unit tangent vector, how would all these vectors look if you had a point of relative maximum or relative minimum of the temperature along this curve?